Hello everyone, this is Chaz. This is my presentation. My topic was on the contributions of the aerobic system, anaerobic glycolytic system to repeat sprint ability. The title of the article that I chose to review and relate to this particular topic is titled The Relationship Among Repeat Sprint Test Aerobic Fitness and Anaerobic Fitness in Elite Adolescent Soccer Players. So what we're going to go over in this order pretty much is a review of repeat sprint ability. We're going to define it, give some examples as to what it might look like, talk about the bioenergetics of it briefly, and then give some examples as to what training for each of these bioenergy pathways might look like. Then we're going to go into the study that I chose, okay, and look at to see what kind of evidence exists concerning the contribution of aerobic, anaerobic glycolytic, and the PCR pathways to repeat sprint ability. And what I liked about this study is its use of popularly used tests of each of the different pathways, and then how it correlates performance on these tests with repeat sprint test protocols. Okay, so what is repeat sprint ability? Well, it's the ability to produce the best possible average sprint performance over a series of sprints. And below here, I've just included an example as to what repeat sprint events and activities look like, how they're typically characterized, and they're characterized as bouts of activity that last less than 10 seconds. It's probably maybe about 20 reps, those activities, and this short recovery period, which is typically less than 60 seconds. Next, going to how do we typically evaluate repeat sprint ability? And one of the most accepted and accurate ways is called performance decrement. Okay, the performance decrement score. And how we calculate that is we take the total amount of time spent sprinting, then we divide it by the ideal time for each sprint performance, each sprint bout, subtract by 1, multiply by 100, and then that's how we get our performance decrement. And that makes more sense, because maybe the ideal time is 95% of your maximal sprint bout. Okay, and then we want to see how your performance decreases in relation to that ideal time. Okay, so what are the bioenergetics of repeat sprint ability? Well, it's complicated and it's impacted by many factors, but we can say that PCR utilization and availability is a significant limiting factor. And then the energy systems that are responsible for PCR utilization and availability are the aerobic system, which is responsible for the resynthesization of PCR during recovery periods. This is especially true for recovery periods up to 1 minute. Then we have the anaerobic glycolytic pathway, which is responsible for effective utilization of PCR. And about 40% of ATP comes from this pathway initially during a repeat sprint performance. And PCR again is capable of replenishing ATP, the ATP that's used to do work at the fastest rate possible. Okay, so we know what repeat sprint ability is, and we know some of the bioenergetics that makes maximal repeat sprint ability possible. Okay, we talked about PCR, and with all that comes training implications. Okay, two main considerations of training for repeat sprint ability is the intensity of the work intervals and the work to rest ratio, okay, which is basically just looking at how long do you spend working in relationship to how long do you spend resting. Now, intensity gets very vague, and that's when things get confusing because intensity in the literature is measured in many different ways. And we see two different ways it's measured here. We see 100% VO2 max. We see 120% to 140% lactate threshold. In some other areas in the literature is measured as a percentage of one's maximal sprint ability, so maximal power ability, which would seem like it makes more sense. But again, there's some limitations in all this, and it's what makes repeat sprint ability research difficult to produce, but not only that, but reproduce and also to implement. Well, the overall aim and agenda of this study is to examine relationships between aerobic fitness using estimated VO2 max obtained from a 20-meter shuttle test, okay, which is considered a strong, valid, and reliable indicator of aerobic fitness. Anaerobic glycolytic ability using the Wingate, which is considered a reliable and valid indicator of anaerobic fitness, anaerobic PCR pathways using max sprint times, and then finally repeat sprint ability, which will be measured by 2 repeat sprint tests developed by the researchers of this particular study. So the statistical analysis that was used on these variables were Pearson correlation, and that was computed between peak VO2 max, wind gate, and performance decrement scores for a repeat sprint protocol of 12 by 20 meters, and then a repeat sprint protocol of 6 by 40 meters. Okay, so Pearson correlation was run between all of those measures. And we're going to go and look at what they found when they did that. Briefly about the methods, the repeat sprint protocols used in this study were a short and long one. The short was 12 by 20, the long was 6 by 40, and the performance decrement scores of each of those protocols were correlated with one of the following 3: estimated peak VO2, they were correlated with wind gate test results of the population, and they were correlated with the population's max sprint times. So what were the findings of this study? Well, with regards to the long repeat sprint test protocol, they did not find any correlations between the performance decrement scores of that and peak VO2. And this here is just giving you an idea as to how that protocol was run. 6 repetitions, 40 meters, 5 seconds, 30 seconds between reps, and 1:6 work to rest ratio. They did, however, find a significant correlation between performance decrements in the short repeat sprint test protocol and peak VO2. Okay, and again, this here is a brief example as to what they did. It's 12 repetitions, 20 meters, work time 3.5 seconds, recovery between reps about 20 seconds, and work to rest ratio about 1:5. Okay, and towards the end of the presentation, after we look at what the findings were, we're going to kind of talk about what we think these findings mean. Okay, so now let's kind of talk a little bit deeper into the findings, and let's start with aerobic contributions. Now, why did they find a correlation between one of these repeat sprint test protocols and not the other? Why did they find a correlation between the short sprint protocol and not the long one? Okay, because if we were looking at these protocols from a bioenergetics perspective, you may argue that there really is no significant difference between these protocols. And if we were looking at this from a bioenergetics perspective, we would be focused on time spent working per effort. Okay, we would look at the differences between the 2 protocols in that area, the intensity of each effort, the work to rest ratio, and the length of the recovery periods. Okay, and we would be thinking about the recovery periods, keeping in mind that bouts of rest, up to 1 minute is heavily dependent on the aerobic system. So, and when we look at that, what do we see? 30 seconds for the long sprint protocol and 20 seconds for the short. That doesn't appear to be a big difference, and it's still under 1 minute. So again, there doesn't appear to be a significant surface on the surface of these protocols. Yet one was correlated with VO2 max and the other was not. But what we do see, though, is maximal sprints occurring over 6 reps versus 12 reps. So that's a large difference. And so it may be the answer as to why only one of these protocols were physiologically related to aerobic fitness. There may be a correlation between the number of sprints performed and, again, whether or not aerobic fitness and capacity is going to be a significant contributor to the performance of a protocol such as that, a protocol with high volume reps. So now, what evidence were PCR contributions, anaerobic sprint ability, glycolytic contributions? Well, there was a significant correlation between in this study we used the wind gate to measure times and low performance decrement scores. Okay, and wind gate typically gives us peak power, mean power, and fatigue, and we would expect to find that. And this is a form to measure because PCR is identified as measurable that repeat sprint test protocols are trying to give us. Okay, mainly due to we want to know what the max sprint was. Okay, so our peak power is capable of replenishing the average synthesizing ATP at the fastest rate possible. ATP we use
and we want
to
to
do
know
work.
we want
If
to
we need
some
to
kind of
do
measure
work
of
at a
fatigue.
very fast rate,
That's
such
what
as
during
performance
a
decrement
fast
score comes
sprint
in,
or
so we
maximal
see the
sprint.
similarities there.
Well, then
How
we need to be
despite
able to
these
effectively
similarities,
utilize PCR, and despite the fact that from a bioenergetic perspective,
well, some strengths of this study, and
appears to
I'm,
be measuring the
they
same thing as
did
repeat
this.
sprint test
They
measurables.
said that they
There was no
used two
correlation
different
found
repeat
between
sprint
the
tests
performance decrement
on the
scores
same group of players.
of
Now, they said they
RST
were the first to
protocols
do
and
this, and I
test
thought that was
results.
interesting because this is a
And this could be
2009
explained,
article.
the
That
researchers
just seems like
attempted to
something that
explain
would
it,
have been done.
and they said this could be
by
due to the
2009.
fact of the amount of muscle used,
But why this was
differences
strength
in
is
the amount
because
of
it
muscle
allowed
between
for
protocols and
them
the
to
number of
look at the
repetitions
relevance of
performed and the
each
recovery time
repeat
between
sprint
those
test
repetitions.
protocol
Now, as far as
to
the amount of
different
muscle
physiological and
used,
performance
let's talk about that first.
measures.
Why that may play a role.
So if I
So
have
Wingate would
athlete
be
A,
measuring the ability or your
okay, and
ability
I have
to perform
and I take
repeat
3
anaerobic bursts
different
of
performance
energy
measurables
in more
from him,
localized areas
and
of
I
muscle.
relate them to one protocol.
Whereas repeat
And I see
sprinting
no correlations,
tests
but I relate them to
measure
another,
repeat
and I do see
anaerobic bursts of
correlations.
energy
Saying,
ability across
on the surface,
large
the protocols
muscle
may not look
cross-sectional
different,
area. Okay, so more
but
global.
that would spur
area
further
of
investigation. Like, okay,
So
well,
even
they
if
don't
the
look
work
different,
times and
and
the
they
rest
don't,
intervals of
in
both
theory,
testing
they don't seem
protocols
different from a
appear to be
bioenergetic
the same
perspective,
or appear to be bioenergetically
so
similar,
I thought that was
fatigue
a
measures
strength of this study.
will be different, simply because of
Well,
the fact
everyone, that
one is
concludes
measuring local
my
fatigue
presentation
and the
of
others,
my
measuring
review
more
of
global
this
fatigue.
study. Hope you picked up some new insights on that, and thank you for listening, and see you later.